And since he's got to hook up his laptop, I could tell you a story about him too. Actually, I'm not going to tell any of the good ones. But I did have a quote of Ross's, and maybe he doesn't remember this, but back when the IETF proceedings were actually Xeroxes because people used transparencies, I was doing a CLMP talk because I got stuck doing OSI. Don't ever get stuck doing OSI. I'm not now, and neither's Ross. I asked him if I could borrow some of his slides to use in a presentation, and he told me not to hide my eyes but to plagiarize. And it always stuck with me. Anyway, I think Ross is almost ready, and he's going to talk about best practices for ISP security. If we can get it to... Oh, good. The slides just appeared online, so if you need to see them, if you want to see them, then hit reload. Thanks.
Thank you. I do sort of remember saying that about plagiarizing. I do sort of think that, at least in the IETF, it would be nice if there was more attribution given when plagiarizing is done. But you did attribute it, so you did right. So I'm going to talk about NRIC best practices for ISP security, and I will explain what NRIC is. I'm going to start off with an overview of what is the Network Reliability and Interoperability Council. I think this slide is the only time when I'll tell you what NRIC actually stands for, but I'll talk about where it came from and so on. I'm going to talk about the best practices for security, talk a little bit about where NRIC best practices came from, and then talk briefly at the end about next steps. So what is NRIC? NRIC is a federal advisory committee which is chartered by the FCC, or the Federal Communications Commission. So NRIC exists because of the charter from the government. However, NRIC really is not a government agency, or it's not a government group. If you look at the people who participate in NRIC, most of them are service providers, or the majority is service providers. The next biggest block is vendors. So between service providers and vendors, it's the overwhelming set of people participating in this. In the early 90s, there was a series of major service outages in the telephone and circuit switch networks, and several members of Congress went to the FCC and said, what are you going to do about this? And so the FCC chartered NRIC originally as the Network Reliability Council to work on figuring out how to make the existing telephone and circuit switch network more reliable. NRIC has been chartered in sort of 2-year blocks. So the first block did 2 years, and then it got rechartered for 2 more years and so on. And gradually the scope has increased a little bit to consider looking at things like data networks and wireless networks and so forth. NRIC for many years has been developing best practices to promote network reliability. Initially network reliability for the traditional telephony and circuit switch network, and then more recently NRIC has come up with best practices for network reliability and for interoperability in data networks as well. The most recent chartering of NRIC is NRIC VI. They like Roman numerals. I personally don't happen to like Roman numerals, but somebody else does, so the various incarnations are given in Roman numerals. NRIC VI, the charter, probably the biggest change is that the charter has been extended to consider external threats, or if you like, security issues. There's been quite a bit of concern in the government about security issues for a long time. I've personally had conversations with government people about how do we ensure that the internet is more secure well before September 11th, as an example, many years ago. And so the idea was to have this group, which is overwhelmingly a private industry group with service providers and vendors, sort of think about how to make the network more secure. Another difference with this charter, with this particular charter for NRIC VI, is to work again at expanding the number of industry segments involved, so to get more people from cable involved, more people from wireless involved, and more people from internet service providers. And then the third change is to get more on the council, which is sort of the highest level body in this, have more people who have the clout to actually ensure their company does something. If the work of the group as a whole determines we need to do something for security or something for liability, to have people on the council who, when they hear this, can go back and allocate resources. So there's CEOs and vice presidents on the council. NRIC VI is sort of structured in a way that's really pretty common for a lot of groups. There is a council that meets once a quarter. Very rarely they're canceled, so sometimes it's actually slightly less than once a quarter. That is chaired by the CEO of Quest. Traditionally, the council is chaired by a CEO of a large service provider. The last time around, it was Level 3 that was chairing. There's a steering committee, which is basically the chairs of all the various focus groups get together and discuss what they're doing. And then there's a bunch of focus groups where all the real work gets done. So once again, every 3 months or so, the work that's gotten done in the focus groups gets reported to the council. And so the notion is that if there's stuff that really needs to be done, we can go there and sort of wave our hands, and Michael Powell, as chair of the FCC, can wave his hands and get people on the council to listen to this who have the clout to get stuff done. This slide's a little bit busy, and I apologize for that. There's two main things I want to point out here. One is sort of the high-level structure of the focus groups divides things into 4 groups. There's an area worrying about security, there's an area worrying about network reliability, an area worrying about interoperability, and a focus group worrying about broadband. I'll talk later on in this presentation in more detail about the homeland security part of this, so I won't go into the subgroups there. But one thing you might want to notice, I want to once again stress this is not a government group. If you look at who's chairing each of these committees, you notice everybody who's chairing any of these committees, including the steering group and the overall council, is from private industry. In this case, if you include the steering group plus these people here, there's 12 chairs or co-chairs, and 8 of them are from service providers, 3 are from vendors, and then 1's from a major user. There is a slight tendency towards service providers, those service providers who are traditionally in the telephone space tend to sort of all show up, whereas service providers who are traditionally just in the data space, some show up and some don't. So in actual fact, probably every service provider at this point is involved in the data space, but it wouldn't be a bad idea if a few more who are major service providers who are very heavily data oriented wanted to show up. That would be a good thing, and I'd welcome that, and I could point you to the right people to talk to know where to show up. Okay, so going on with the agenda, let's get into a little bit more of security and the best practices for security. I'm going to start off talking about what best practices are, and then I'm going to focus in specifically on cybersecurity. Once again, NRIC has been working for quite a while to develop best practices for reliability in other sorts of networks. One of the sort of primary principles is that this is a voluntary effort of multiple, a lot of people from a lot of organizations coming together and working cooperatively. So to some extent, we're sort of doing this without regulation, partly so that the people in Congress and elsewhere who might be concerned about reliability and security can understand the right stuff is getting done and won't need to do any regulation. I think there's a large amount of interest in private enterprise, service providers, vendors, and the government right now in understanding that regulation is something to be avoided wherever possible. So the implementation is optional. There are some best practices that are concerned with things like surges of water based on hurricanes, and if you're in Saskatchewan or Alberta, you probably don't need to worry about that one. So there certainly will be cases where there's best practices that don't apply to specific service providers. However, these best practices have been developed by a large number of people from a large number of service providers and have been validated based on outage data. And so there has been an ongoing effort to determine the effectiveness of these, and has been a pretty good confirmation of the effectiveness. In the last council, which ended about roughly a year and a half ago, at a end of a year, there was a survey where they went to a very large number of service providers and said, for every single one of this long list of best practices, do you implement it? How much does it cost you to implement it? Is it risky to not implement it? And they determined that the vast majority of service providers already implemented the vast majority of best practices, and this is of the best practices for reliability in both telephone and data networks. Most of the service providers said that the cost of implementing specific best practices was low, and that they are effective in preventing outages, and that there's a risk to not implement them. So it shouldn't be a big surprise, if the folks who develop the best practices then get to look at them and say, is it effective or not, that they will find them effective, but I think it's nonetheless reassuring. I don't want to say that much about this. This is a list of principles that the folks developing best practices use. Number 2 there, we don't endorse specific commercial products or expect people to go out and buy documents. For number 4 there, talks about using best practices that are already implemented. So in many cases what this does is document things that people have already done to prevent various forms of outages that have already been seen. They're developed by industry consensus, and they're verified by industry consensus. The current work on best practices is focused on this homeland security area, and that's split into 4 parts. There's physical security, which includes things like controlling who has access to manage your machines. Somewhere in there's probably something about not using simple passwords, exchanged in the clear, and don't put the name of the manufacturer as the password on your equipment. There's cybersecurity, so how do you deal with worms and viruses and DOS attacks and so forth. There's a group thinking about public safety. That group is concerned with how the telephone network, the wireless network, the data networks can be helpful to other parties who are concerned with public safety. So how do the police and the fire and the disaster recovery people make use of network resources to make it faster to recover from various problems? There's also a disaster recovery and mutual aid group. It's very common when there are hurricanes in the south or ice storms in the north or buildings falling down or any form of disaster that one service provider is going to get hit a lot harder than others, and so the other service providers in many cases will come to their help. When there was a big ice storm in Canada a few years back, service providers all across the U.S. had people up in Canada helping to restring wires. When there was actually an ice storm down in the south recently, and again, service providers all across the U.S. and Canada had equipment down in the south helping to restore stuff. So that mutual aid and working together to recover from disasters is a ongoing and common practice. So let's focus in on cybersecurity. The cybersecurity group is chaired by Bill Hancock, who's the head of security for cable and wireless. So the charter is to generate best practices for cybersecurity in both telecommunications and internet and data networks. They've come up with a long list of best practices, the majority of which are aimed at prevention. I think there's actually been a couple more best practices developed since the initial set. But they came up initially with 100 best practices for prevention and 45 for recovery. So there's sort of a lot of things that one could do to improve the situation. Let's look at how some of this applies to the slammer worm, because that's one where it actually could have been prevented, and in a few cases was actually prevented from accessing some networks. One issue is the propagation time. My understanding is that there have been presentations on the slammer worm. Everybody's very familiar with that, so let's just go very quickly over it. I think everybody's familiar with the very rapid propagation time that one worm produced another copy of itself on the average. They think about every 8.5 seconds, which if you do the math means in something like 10 minutes every atom in the universe has a worm on it, which implies that somewhere before that point it's had to start slowing down because it's running out of uninfected systems to attack. What this means is that you can't really, if you solve it by waiting till it happens and then reacting, you've basically let the network collapse and then try to put it back up again. If you want the network to keep operating, you have to do something a priori to stop something of this speed from hitting you. One thing that was quite interesting to note is that there was a number of the NRIC best practices for prevention that could stop the slammer worm, and there were some cases of service providers that were either completely unaffected or only minimally affected because on the most part they had already deployed some best practices that happened to be effective here. This next slide gives a list of best practices that are documented and written up in the NRIC best practices and which are applicable to stopping the slammer worm. To look at a few of these, do I have a pointer here? Okay. I actually meant to bring my laser pointer and forgot it at the last moment. Pushing it, shoots. If you look here, there's 3 in the middle here, the security, hyper patching, patching, and software patching over here. The vulnerability that the slammer worm exploited, as probably everybody already knows here, the fix for that was available multiple months in advance. So for any service provider that had kept up to date on all of their patching, they'd already fixed the vulnerability. There's also a best practice about system inventory saying essentially you need to know what equipment you have out there. Well, obviously you can't patch equipment unless you know you have it, right? So that's, again, applicable in a sense to preventing the slammer worm. There's stuff about validating source addresses. Again, if you validate source addresses, the slammer worm used random source addresses, so the overwhelming vast majority would just get wiped out right at the first router if the first router was validating source addresses. There's also best practices about dealing with denial of service attacks, things like rate limiting traffic and so on, which again would cut down the amount of traffic that the slammer worm could gobble up. Disabling unnecessary services. So if you have a server out there that's got SQL on it, but you don't use SQL on that server, shut it off, and then the slammer worm would not have been able to get in there. You got a question?
Yeah, it strikes me as extremely unlikely that a significant number of those machines were actually in ISPs. They were in-user hosts, right? So it's not the patching practices of the ISPs, but the end users that would have affected the ultimate vulnerability of the network to the slammer worm.
Well, but there were service providers who, well, of course, there's also the amount of traffic that can bring you down on its own. There were cases of service providers turning off UDP ports that were not used a priori and just dumping the traffic, as an example.
So can you safely turn off UDP ports over 1024?
That's a good question. You could do it and see if somebody complains. Or you could rate limit it. I believe you can safely rate limit it if you have boxes that can do rate limiting. But validating source addresses is another thing. Even if you validate at the ingress to the service provider, you could have an entire corporate network out there, but you can still validate the source address if it's not coming from that corporate network, or if the source address doesn't say it is, then you dump it. That allows the slammer worm to get around inside an enterprise that you're not concerned about, but it can still stop it. This is an example of a best practice, and you can see here, I'll pause a minute to read it. Right? Service providers and network operators should disable unneeded network accessible services that are not needed. That sounds a little redundant there. Or use on any element or management system, and so on. You'll notice this doesn't really tell you exactly what to do, right? It doesn't tell you turn off this one particular service, but it tells you sort of things to think about. And that tends to be common to the best practices. For prevention of cyber attack is cheaper in general than responding if you can do it. Most of these sub-bullets here really were summarized, I think, in 4 words by the VP of Engineering of Comcast Cable when he said, Outages bum out customers. And there's a bunch of implications of that, but it's a bad thing. There's also the matter of the support costs, right? If your network is going down, you've got to spend a lot of time and money and effort doing it. That costs, well, you spend time and effort, that costs money. I believe, and I think that Bill believes, and I think most, that the fact that we have 105 best practices on prevention implies a lot of people believe in the long run it's cheaper to prevent the outages than it is to wait till things go down and then try to put them back up again. So let's talk about next steps. I'm recommending that people go out and just take a look at the best practices for physical security and the best practices for cybersecurity. Look at them, see what you think of them. If you find best practices that you believe are appropriate and that would cut down on some forms of attacks that you're seeing in your network, then if you can get your management to let you deploy them, then do so. Again, in a large extent to hope to either prevent future attacks or to at least reduce the severity of attacks. Likely there will be some you can prevent and some you can mitigate and some that will sort of slip through. If you look at the best practices and you don't like them, or even if you like them and you think there's a few places they could be a little bit better, certainly feel free to participate in the NRIC efforts, and there are some more information ongoing in the next few slides as to how you can do that. For the intended use, I mostly want to emphasize they are voluntary, and there is the urge to look at them, prioritize them, take the ones that you feel are the highest priority, and deploy those first. In order to find out more about best practices, you can go to the best practices main page, and the URL is there, and you can, of course, pull down these slides from the net. The best practices main page has a rather long URL. It's probably faster to type in www.nric.org, let that page come up, and then right in front of you is best practices, and you click on it and it takes you to the main page. You can follow that on to say, view best practices. You go to the best practices selector tool. If you click on cybersecurity and hit submit, you get that bottom URL with the cybersecurity best practices. If you click on physical security and hit submit, you get the physical ones. If you click on both and hit submit, you get nothing, because it's the and of all the things you click on. So that often catches people the first time they try it. When you get the best practices selector tool, don't click on very many things. If you click on nothing, you'll get every best practice. If you click on everything, you'll get nothing. For information on NRIC, you can go to the NRIC website. You can send email to the chair of the steering committee, who's Pamela Stogura-Axelberg from Quest, or you can send email to the designated federal officer from the FCC for supporting NRIC VI, and that's Jeff Goldthorpe. And I want to summarize here with sort of a call to action. And security is a complicated issue because the networks are complicated and there's a lot of ways to attack them. The fact that NRIC has come up with over 100 prevention best practices, over 150 cybersecurity best practices, and over 200 physical security best practices sort of implies that other people believe it's complicated. But there are some things that are sort of obvious that need to be done, right? There's some basic network hygiene that makes sense, and some of it's not being done. I had a conversation not too long ago. I actually have quite a few conversations where I ask service providers, what do they do for security and so forth? And a while ago, I was talking to somebody from a network and about how they stop various types of attacks. And I asked them, well, what do they do for packet filters? And they say, oh, we don't use packet filters at all. I said, well, why not? He said, well, they'd be really useful if we could, but the particular routers we have, if you turn on packet filters, the performance collapses to the point where you might as well just disconnect the interface. So that's what we do. We disconnect the interface. So I said, well, why don't you just buy routers where you can turn on packet filters? And he said, oh, well, my management's already made the decision as to what to buy without looking at any of the details, and so I just have to go with it. And so partly thinking about that conversation and partly thinking about the conversation last night at the security BOF, I thought maybe the most helpful thing I could do here is give network operators and engineers sort of stuff that they can take to their managers to scare the bejeebies out of them. Right? Because there's some managers out there who need their bejeebies scared. And so I think the first thing to start with, that I'd probably start with, is this slide, which is nothing more than the data which I took from CERT. You go to www.cert.org, click on statistics, and you see the number of security incidents that have occurred over the last 7 years. There's also data now for the first 3 months of this year. And there's really two things that are pretty obvious that, you know, even a manager's manager could get out of this slide. One is that it's a very, very rapid increase, and the other is that it's a very, very big number. You know, 82,000 security incidents in 1 year is an awful lot. And it's sort of sensible that most of the incidents don't even get reported to CERT. So, you know, there's an awful lot of problems out there. We all know that, but we need to convince other people that it's worth deploying fixes. They also have vulnerability information as well there. And there's one more. If this does not scare enough of the bejeebies out of your managers, there's one more place to go. Poking around, I found a paper by a lawyer, actually the co-director of the program on law, science, and technology at Stanford University is Margaret Radin, or Radin? But you can just go to Google and do a search on her name, R-A-D-I-N, space, denial, space, of, space, service. Do a I feel lucky click, and you'll get right to a paper that she wrote on the potential liability of of service providers who fail to protect their networks. The paper is called Distributed Denial of Service, Who Pays? It's on the Mazoo Network's website, and if that doesn't scare your managers into letting you secure your network, then I don't know what will. Thank you. I think she asked if anybody had any questions, but I didn't hear the microphones going on. So if anybody has any questions. Thank you.